I'm Anil Kumar sharing with you questions from the test paper. Let's look into it in details. The question here is, consider the function f of x equals to 3 times 1 over 3 to the power of x plus 2. Determine the horizontal asymptote, y-intercept, whether the curve is increasing or decreasing, and domain and range. Sketch the graph of the function. I'd like you to pause the video, answer the question, and then look into my suggestion. Right now, let's analyze the equation given to us. It is f of x equals to 3 times 1 over 3 to the power of x plus 2. Horizontal asymptote. 2 represents horizontal asymptote. So we have horizontal asymptote as y equals to 2. Correct? Now we need to find y-intercept. Y-intercept really means what is the value of the function when x is 0, right? That is y-intercept. Y-intercept is f of 0. So just substitute 0 here. What do you get? You get 1 over 3 to the power of 0 plus 2. Anything to the power of 0 is always 1. So you get 3 plus 2, which is 5, right? And therefore, y-intercept is 0, 5. Whether the curve is increasing or decreasing. Now b here is 1 over 3, correct? So since b equals to 1 over 3, base 1 over 3 less than 1, that is between 0 and 1, the graph is decreasing. Domain and range. For the exponential functions, domain is always all real numbers. Now, we already know that the function is decreasing and it has a vertical asymptote, right? It has a horizontal asymptote, y equals to 2. So we can also write the range of the function, but we'll wait for sketching and then writing down the range. Range of an exponential function is always restricted, right? So we'll write that later. Let's begin by first sketching the horizontal asymptote, right? So which is y equals to 2. So sketch a line y equals to 2. Function has to approach this line as x approaches a very large value, right? Now we will mark the y-intercept. Y-intercept is 0, 5. So at 0 we have 5. So that is the y-intercept for us. And we know the function is decreasing. Now to get other points, what we can do is we can find the value of the function at 1, minus 1, 2, right? And then figure out what those points are. Now, so the function here is f of x equals to 3 times this. So let us find the value of the function at 1. Okay, let's calculate this value. So if I write 1, I get 3 times 1 over 3 plus 2, which is 3 divided by 3 is 1. 1 plus 2, which is indeed 3. So the value at 1 is 3. So we get this point. Good. We can also find the value of the function at minus 1. So if I write this as minus 1, I get 3 times 1 over 3 to the power of minus 1 plus 2, which will be 9 plus 2 as 11, right? Minus 1. This really doesn't help us since I have taken a scale, but it tells you that's like going very, very high, correct? 11. So it's kind of there, right? So we will assume this to be, this is 4, 8, 12. So we'll assume it to be around that place. Let me mark 1. How does it matter? Let's say this is at minus 1, okay? And let us also take one more point, and this one will be at 2. So it'll be 3, 1 over 3 square plus 2, which is 1 over 3 plus 2. So 2 slightly more than 2. So that is kind of here, 1/3, right? So that is kind of here. So joining these points, we get our graph, correct? So let us join these points and draw the curve. So let me use a darker ink so that it's very clear. So what we get here is kind of like this. So approach the line, that is the whole idea, don't touch it, right? And that arrow indicates on the both ends that it extends. And with that, we can write down the range. That range is y belongs to real numbers and y is greater than the horizontal asymptote, which is 2. So that is how you can solve such a question. I hope that helps you. So these are the right steps to move forward and sketch a function, right? So even if these questions are not asked for, this is what you have to think before sketching. So that's the whole idea. I hope you understand and appreciate it. I'm Anil Kumar. You can subscribe to my videos and learn a lot. Thank you and all the best.